We will discuss two approaches how to determine the empirical and molecular formula from the percentages that are given. And so the first approach would be first we are going to determine the empirical formula, and from the empirical formula we will determine the molecular formula. And in the second approach we're going to determine first the molecular formula, and then from there we'll determine the empirical formula of the compound. Let's start from the first one. So approach number one. First we're going to determine the empirical formula. I talked a little bit about this on the previous video, so I will not go so much into the detail here, but one thing that we need to know is that if we have the percentages, our plan is to convert the percentages to mass and convert the mass to moles. And the reason we do here, because in any formula, again, so just as an example, CO2, this is moles, and we have 1 here, this is also moles. So the subscripts here tell us how many moles of each element we have. So this is the plan. Now, what we can do is we can write down the following. So we have carbon, hydrogen, and oxygen. So we can write down the following. We have carbon, which is 55.17%. There is hydrogen, which is 8.046%, and it says that the rest is oxygen. So the percentage of the oxygen will be the difference of this, so 100% minus the sum of these two, plus 8.046%, which gives us 36.784% of oxygen. That's how many percent of oxygen we have. And so here I can add the percentages of the oxygen. I'll put oxygen 36.784%. Now, one step, we are going to convert this to mass, and in order to do it, remember what we do is we assume that we have 100 grams of a sample. So let's just put here, assume 100 grams of a sample. When I do this, I get the same. So I have now C 55.17 grams, H 8.046 grams, and I have oxygen 36.784 grams. So in one step, I went from percentages to the mass. Grams, grams, grams. Second, also I'll go in this direction. We convert the mass to moles. So use the molar mass, M. Divide the masses by their molar masses, and what you will get here is that number of the moles of the carbon. Let me put it on this side. So number of the moles of the carbon will be equal to 55.17 grams divided by 12 grams per mole, which gives us 4.5976 moles. Number of the moles of the hydrogen, 8.046 grams. We divide this by 1 gram per mole, molar mass, 8.046 moles. Finally, number of the moles of the oxygen, we're going to take 36.784 grams divided by 16 grams per mole, which gives us 2.299 moles. Okay, so now I have the moles, and I can write down this, that I have carbon 4.5967, I have hydrogen 8.046, and I have oxygen 2.299. This is what it is right now. We got this formula, and of course this is not an accurate formula. These are the moles, but we cannot have a compound represented with this formula because we need to have simple numbers. How are we going to simplify this? Well, as we discussed in the previous video, to simplify, divide by the smallest number of the moles. In this case, oxygen has 2.299, so divide by this number, 2.299. If I do it, I'll have 1 mole of oxygen. So let me put it here, 1. Oxygen will be 1. And for the hydrogen, what I get is H 3.5. And I round off a little bit the numbers, and I ignore the significant figures here. So for these type of problems, you can ignore the significant figures and you can round off a little bit. So 3.5, and I have carbon, which is 2. So C2H 3.5. Oh, okay, this is where we are right now. And so again, this is still not acceptable because we have a decimal here, and we need to now simplify these further. How can we simplify this? The problem here is the 3.5. So in order to simplify it, multiply everything by 2. C4H7O2. And this is the empirical formula because everything here is given in the smallest possible whole numbers. Okay, so let's mark this. This is our empirical formula. And so now we need to determine the molecular formula. Let's see how do they compare. So I want to compare the molar masses of the molecular formula and the molar mass of the empirical formula. In order to do this, we need to first find the molar mass of the empirical formula. So M of the empirical will be from here. So 4 carbons, 12 grams per mole, plus 7 hydrogens, and we have 2 oxygens. So if I add them together, this is going to give us 87 grams per mole. And from the problem, if we go up, it's given here that the molar mass of the compound is 174 grams per mole. So the molar mass of the molecular formula, the actual compound, over the molar mass of the empirical formula is equal to 174 over 87, and that is equal to 2. So molecular formula is 2 times higher than empirical formula. This means that everything here, all the moles, the subscripts, need to be multiplied by 2. And if we do that, we're going to get C8H14O4, which will be the molecular formula of this compound. So we got the 2 answers for empirical and molecular. It's possible sometimes that they will be the same, that the M of the molecular will be the same as M of the empirical. It is possible. The only thing is that the empirical formula can never be larger than the molecular formula. Alright, so this was the first approach. Now second approach, we said that here what we can do is we can go from the molecular formula to the empirical formula. How are we going to do this? If we go back to the percent compositions and remember that these percentages tells us how many grams of each compound we have in a 100 gram of sample, we can find actually how many grams of carbon, hydrogen, and oxygen we have in the molecule with a molar mass of 174 grams. So 55% of carbon, this means that if I want to find the mass of the carbon, it's right down here, so mass of the carbon will be equal to 174 grams, the molar mass, times 0.5517, this is the percentage of the carbon, which will give us 95.99, rounded off to about 96 grams of carbon. Second, let's find the mass of the oxygen. So 174 grams, we multiply by the percentage, 0.36784. This is about 64 grams of oxygen. Okay, so now finally the mass of the hydrogen will be 174 grams multiplied by 0.08046, and this gives us 14 grams. This is how many grams of each element we have in the compound. Now, in order to find the molecular mass of this, we need to convert these to moles, right? So find the moles of each. Moles of the carbon will be equal to 96 grams over 12 grams per mole. And we get 8 moles of carbon. Second, moles of the oxygen will be equal to 64 grams over 16 grams per mole. So we get 4 moles of oxygen, and for the hydrogen, moles of the hydrogen, get the mass of the hydrogen, it's 14 grams, so 14 grams divided by 1 grams per mole, so we have 14 mole. Now if we put all of these together, including the hydrogen of course, what we'll get is that 8 for the carbon, or 4H14, and this is the molecular formula. Okay, so this is the molecular formula, because what we did, we actually used the molar mass of the compound, and in order to find the empirical formula we need to simplify this. If we divide by 2, we'll get C4O2H7, and this will be the empirical formula. I noticed that the order of my elements are different. Here I had CHO, here I have COH, but remember, it doesn't matter. These are just empirical and molecular formula. These are not about the structure, they're not structured formula, so the order doesn't matter. Okay, so 2 ways how to determine the empirical and molecular formula. If you like this video, please subscribe and visit Chemistry Steps for more problems and discussions about chemistry.